Example 2, a 4-H member raises only goats and pigs. She wants to raise no more than 16 animals, including no more than 10 goats. You should be kind of getting a feel for inequalities there. No more than. That feels like an inequality to me. She spends $25 to raise a goat and $75 to raise a pig. She has $900 available for this project. Each goat produces $12 in profit and each pig $40 in profit. How many goats and how many pigs should she raise to maximize the total profit? Okay. So again, I like to start at the end because that tells me the variables. I'm going to call goats X and pigs Y. And also it says straight up, she'll maximize profit. So we know this is a maximize problem. Okay. So I know what my problem looks like now. It's maximize something and subject to some constraints. So we're talking about profit. So I would go back and look for the numbers that are talking about profit. Okay, well, it looks like each goat produces $12 in profit and each pig is $40 in profit. So right there, I'm going to use the letter P. You can use Z if you want. You can use Z every single time, but I like to use a descriptive letter like P for profit. So the profit is going to be $12 for each goat plus $40 for each pig. Once you've seen one of these problems and you understand that they're the same thing over and over again, you should kind of get in the flow a little bit. Okay, so the rest of this is some constraints. So she wants to raise, you go back and read it again. She wants to raise no more than 16 animals. That sounds like a total to me. No more than 16 tells me something is going to be less than or equal 16, but it's animals. So that means goats and pigs. No more than 16 goats and pigs. So that should tell you that the number of goats plus the number of pigs is less than or equal 16. That equation happens all the time. X plus Y is less than or equal something. Okay. And then it says no more than 10 goats. So that's only talking about goats. So that's only talking about X. X is less than or equal 10. Okay. The next set of numbers all have dollar signs in them, so you would expect those three numbers to go together. She spends $25 to raise a goat and $75 to raise a pig, and she has $900 available for this project. Okay. It's not as obvious that that's an inequality, but think about it. Can she spend $1,000? No, because she has a limitation. And a limitation is an inequality. She can only spend less than or equal to $900. And so if you think about it that way, it was 25 for a goat and 75 for a pig, X and Y. That's going to be 25X plus 75Y is less than or equal 900. Like that. Okay. Then also, almost all of the problems are also going to have this at the end. And again, like the last problem, what does that force to happen? No negatives. We can't have negative pigs and negative goats as part of our solution. And that's what forces that to happen. Okay? The problems are all going to look pretty much like that. So let's go back to Desmos. We have, where are we? Okay. X plus Y is less than or equal 16. X is less than or equal 10. Okay. 25X plus 75Y is less than or equal 900. X is greater than or equal 0. Y is greater than or equal 0. Okay, now again, it gets kind of difficult to see with all the colors. I think the easiest thing to do is change them all to the same color. Let's try blue this time. The solution set is the region that's been colored in all 5 times for all 5 of those inequalities. And so you can see it's this region right here. So we want to use the method of corners, so let's find those corners. We've got those corners right there, okay? So you need to copy that picture over, okay? Copy that picture over. So we can just do kind of a quick sketch. I don't need to do tick marks. I don't need to make it look super awesome. It just needs to be good enough. Because we're not dealing with negatives, we only need the first quadrant, okay? So we had one line that looked like this, and one that was a little steeper, and then one that was vertical, okay? So these were my corners. And this is my feasible region. Sometimes you'll see somebody will put like the letter F right there for feasible region. That just means that whatever the solution is, it has to be in that region. Any other number outside of that region there isn't going to make any sense, okay? You'd have negative pigs or something. You'd have too many pigs or something, but it has to be in that region. So again, we're trying for the corners. Desmos is really powerful for finding those corners. Zero, zero, 10, 0, 10, 6, 6, 10, 0, 12. Okay. So since we are maximizing, the last step is finally to look at that equation. One common mistake that people will make is they'll try to graph that, or they'll try to do something with that before it's ready, okay? I'm not ready for that equation until I get all the corners, and then I can plug in. So obviously this one's going to be 0. 12 times 0 plus 40 times 0 equals 0. 12 times 10 plus 40 times 10 times 0, sorry, equals 120. 12 times 10 plus 40 times 6 is 360. Use a calculator for that if you want to. I've already done it ahead of time. 12 times 6 plus 40 times 10 is 472. And 12 times 0 plus 40 times 12 is 480. Okay. So where's the biggest number? 480? 480 is the biggest number, right? That's your solution. Maximize profit. So the solution, max P equals $480 with what? 0 pigs and, is that right? X was pigs? X was goats. X was goats, so 0 goats. And Y was pigs, so 12 pigs. Okay, great. So we do that over and over and over.